When I was going back from work last week after a long day, I think all of you here knows what long days are all about, I realized I have only seen the sun for 10 minutes when I was walking from the office to the canteen. Even the sun has been shining the whole day. When I walked through the hallways, I started to consider we as human beings are spending a lot of time in buildings. We spend 90% of our time in buildings, 90%, for learning, working, shopping, sleeping. So there's no wonder that we are spending a lot of energy in our buildings, because they are extremely important for us, how we feel as a human being. What I would like to do today is talk about buildings. I would like to bring you on a very, very exciting journey. A journey where we're moving into the future and how buildings could look like. I really hope you're ready for that. That will be exciting, I promise. But how do you actually see a building could look like in the future? Probably not. That's more my kids. And your kids probably. No, buildings would probably look more like what you see here. Can you see what it is? I think a lot of you can. It is Kiev. Yes. So, before moving into the journey, I would like to say, why is it so important for me to talk about buildings today? Why is it so important for me to talk about buildings today? Because buildings consume 40% of the globe's energy and are responsible for 36% of all the CO2 emission. So absolutely the biggest consumer of energy. So buildings are absolute the biggest. But does it have to be like that? No, not at all. And that's where we are coming in here with a journey. If you are now starting this nice journey together with me, let's try to look at 3 scenarios. I think you all are aware, when you are paying your heating bill, that's actually one of the most expensive bills you pay. Think about that. Every month you pay, month after month, a lot of money. So that's why I would like to drive you into the future now and what innovation in the building space is all about. And this is actually where our exciting journey would start. I have selected 3 scenarios. The first scenario is about smart apartments. Second scenario about smart buildings like hotels. And the third one about connected buildings, because buildings has a lot of neighbors. So that will be the 3 scenarios I would like to move into. Let's take the first one. What if you move into the future and you considered, what would you say if the temperature of your apartment would simply follow the natural rhythm of your life? When you go to sleep, the temperature goes automatically down to the level you would like. When you go on vacation, the temperature is turned off because nobody is in the room. Why have temperature on? If it is a stormy day in April, suddenly the temperature goes far down. Your heating system will automatically peak up, so your inside will have a comfortable, great life. And of course, your heating system will be controlled by your smartphone via an app. That's how we see that. If we then move back today, and I'm telling you, all that is possible today. What I just told you is actually happening today. It's already happening out there today. So why are we not moving faster as we actually are? Because we need to fix some basics first. In some specific European countries, we have more than 500 million radiators with on-off manual valves. And if we add whole Europe, including Ukraine, it would be far more than 500 million. I don't know if you know what an on-off valve actually is. On-off valve is like this one, could be many others. This is actually a one you put on your radiator. If you turn it up, you're getting more hot water into the radiator. If you turn it off, you will get less hot water into the radiator. But the valve here doesn't care if it's 40 degrees, 20 degrees, or 0 degrees in your room. Doesn't care at all. And if you then start thinking, when you're having a shower in the evening, and you say, okay, one from my family will have a shower in the morning, why should I turn off the hot water? Why should I not just let that run the whole night? Would you do that? Probably not. If you're going back with your car in the evening, and you know you will use your car again in the morning, would you switch off the engine during the night? Probably yes. But that is exactly what we don't do with our heating system. We are allowing hot water to go through the heating system 24/7. In other words, we are wasting enormous amount of energy by doing that. And the good part is, it's a very, very simple solution. So substituting an on-off valve with a thermostat. A thermostat works like, it's measure the temperature in the room. If you want 20 degrees in the room, it's only put in the hot water you need to get 20 degrees. When you have 20, it's shut off. And then you say, yeah, but that's very expensive. That's probably not for me. I can tell you, this solution has a payback time of less than 2 years. And it will save a lot of energy. And then we can say, we are even now moved to the next level also, from the mechanical TRV into what we call the digital thermostat. A digital thermostat is actually one based on Bluetooth, connecting to your app. So whatever you do with your heating system, you're just controlling that with your app. Again, going on vacation, you program it. If you have rooms you don't want to be too hot, you program it. And that is already there. And then you can ask, what are the benefits? Okay, short payback times is interesting, but you can save more than 30% of your heating bill if you're just doing this very simple piece here. If I'm trying to go into the next scenario, hotels, how will that look like in the future? In the future, there's no doubt that people visiting a hotel several times, they want exactly having the right temperature for the room. They know exactly what kind of coffee they would like. They know exactly what kind of showering temperature. So with all that forward-going, people will be treated much more as individual as they are today. That requires a lot of digitalization. It requires a lot of sensors. It requires a lot of data. But it's possible today. If we then again move a little bit back to where are we today? I think all of you have tried that, taking a shower in the morning, and then the neighbor is also taking a shower. Then you're getting hot, cold, hot, cold. You might be awake, but it's definitely not very comfortable having that. And that's where we can say, what is happening here? Why is that happening? That's what calls a hydronic imbalance. Exactly you see here. When you punch holes in a tube, most water will get out of the first hole, and less second. That's exactly what is happening in buildings. That's why apartments closest to the heating source, they will get so much heat, they need to open up the windows, because they can simply not even take off all the clothes. Whereas the people living on 5th floor, they are freezing cold, they need to find jackets and a lot of other stuff. The reason for that, because the house could probably have enough heat, but we are simply not distributing the heat in the right way. So that is actually where we're saying, If we fix that, and again, we are talking about solution here, very, very simple solution. It can save, again, 30% energy, payback time is less than 2 years, and most important, you will get a much more comfortable apartment or house to live in. The last one of my 3 scenarios is connected buildings. As said, all houses, they have neighbors. And think about, today we are looking at all houses as energy consumers. They are all consuming energy. We need to ensure we're getting the right energy to the houses so they can get the right system up running. But tomorrow, a lot of buildings will be energy producers. In Denmark, we are running now with many supermarkets. Supermarkets have a lot of surplus energy based on all the fridges, refrigerators, compressors they have. So we have supermarkets in Denmark today who are providing heat for 1,000 houses. We could say data centers. We could say a lot of other. So it's not only combined heat and power anymore who will provide heat. That's where we suddenly will see a totally other energy system forward going. And the other one is we are getting much more intelligent systems in the future. When we know the weather forecast, when we know the wind will change from east to north, when we know the temperature will drop 5 degrees, already today we can actually start ensuring we are getting the right balance for heat to make that most comfortable. So, what is happening today? Already today, we are running with artificial intelligence in our houses. We are predicting the energy consumption because we know how the weather actually will be. We are also in Nordic between 6 and 8 o'clock in the morning. That's typical where all people, they want a shower. That's where you get the big peak. What we are doing now, we are preheating the building from up to 6 o'clock. So during 6 to 8 o'clock in the morning, we are not spending any energy for heating up the building. We are only spending energy to preparing hot water for the showering. And then when it's 8 again, we start heating up the building. That is cutting the peak heat with 20%. And you all know how expensive the peaks are to take care of. And that is actually already happening. But how does the future look like? Do you feel it's too utopian? Is it too far away? So, with engineering tomorrow, the future is actually today. The 3 scenarios I just described are happening today. They are happening today. We still need some basics right, but as said earlier, if we dare to put ourselves in the driver's seat, you and me, we all dare to start taking those extremely simple solutions, move forward, we will actually take a big load out of our big problems for the future. We could see that the 40% of the consumption of the total energy could dramatically decrease. And as I said before, that is the biggest energy consumer. Start thinking about if we could do something dramatic about our buildings. That would not only be interesting for the building, that would be interesting for the whole society. So getting below 40% of the energy and well below 36% of the CO2. That's something interesting. But again, if we want to realize the future, and we have amazing innovations and technologies to do that, then we need to fix some basics today. I think what I'm trying to say here is low investments, low payback time, and high benefits. Again, it's not up to somebody out there fixing this. It's up to us in the room here. If we dare to take the driver's seat position, we can make it happen. Not tomorrow, but actually today. That will definitely benefit our wallet, and it would definitely benefit the planet. Think about if energy efficiency in buildings could become the new normal. That would be great. Getting basics right, fast track, get smarter, connected buildings. In other words, the future is for us, not only for the Teletubbies. Thank you.